Hello YouTube, it is Qnix with another tutorial for you. This is a tutorial for the new effect that I have featured on my channel called My Motion is So Compensated Right Now. This is just a silly, weird, cursed, fun effect, and I discovered it when I was using motion interpolation in FFmpeg. So let me just review before I get into this what motion interpolation is. Motion interpolation is any kind of algorithm that is used when you are taking a video that's at a low frame rate, and you are increasing the frame rate. It is any kind of decision that is made on how to fill in the new frames in between the frames that were in your original video. And the simplest, most straightforward algorithms are just to repeat the frames in the old video until the next frame comes along. And this doesn't really actually look like anything's changed. This just looks like the video at the normal frame rate. And there's also fading between frames, which looks smoother, but it doesn't really add any additional information. There is a third method called motion compensation, where the frames that are in between the original ones that you already had are sort of estimated by accounting for the motion of objects in the original frames. Basically means if you have a video at 15 frames per second and you want to increase it to 60 frames per second, you can use motion compensation, and FFmpeg will do a little bit of math, and it'll try to determine what the new frames in between every fourth frame? Yes, every fourth frame would look like, and will hopefully make the video look smoother. It's not perfect, but it works pretty well. Now, in order to capture most of the motion of the original video, motion compensation does need the frame rate to be reasonable to start with. 15 frames per second looks a little bit choppy in this example, but it's pretty reasonable. You can still see the motion pretty well. So I love to abuse effects and use them for things that they're not supposed to be used for. So when I made this effect, My Motion is So Compensated Right Now, I decided what I would do is I would set the frame rate of the input video to 2. So instead of capturing the motion at something reasonable like 15 or 30 frames per second, I am outputting a single frame every half a second. So I'm basically making FFmpeg decide what the heck to do with the motion in the video between every, well, usually I render my videos at 120 frames per second, so that would be every 60 frames. FFmpeg has to fill in the data between every 60th frame. In today's video, I'm only going to be rendering at 60 frames per second, just so I can get things done in a reasonable time. But the point is, I have a lot of space between frames, and then I'm asking FFmpeg to try to fill in the blanks. And it's simply too much time between frames for this effect to perform the way it's supposed to. But FFmpeg is still going to try, and the output is what we get when I apply the effect My Motion is So Compensated Right Now. So we are going to need a few things. We're going to need Kdenlive, we're going to need Audacity, and we're going to need FFmpeg. There is no way around it. We need FFmpeg for this. Make sure if you check the available filters, something called Interpolate should show up, which it does. We really need this. If you don't have the Interpolate filter available to you, then unfortunately you just need to find a different build of FFmpeg that does, or you need to try to build it from source on your own. I'm running this on Void Linux, and I have also gotten this to run on CentOS 7.9, which is pretty old. So if you're using Linux, even if it's not that new, you shouldn't have any problems. If you're using Windows or Mac, you may have to install it from a different source. But, you know, maybe this isn't an issue for you and I don't have to get too far into it. So, the most important step is actually the last step. I'm going to have to present the steps a little bit out of order because we have to do some prep work before we get into the actual meat of this effect. And I'm going to discuss 4 steps to getting this effect done. The first step is going to be preparing our logo. Most logo editing YouTubers like myself put their own little mark in the corner of a video, and we're going to want to prepare this beforehand in order to ease the use of FFmpeg, prevent the need to render multiple videos. The second step we're going to do is we are going to prepare the source video that we want to use for widescreen editing. We're just going to basically stretch it and scale it to fill the aspect ratio we want, and we're also going to set the frame rate down to 2 frames per second. The third step is we're going to go into Audacity and we're going to apply the pulse stretch effect to get that weird echo. And the fourth step is going to be the meat of the effect. It's going to be where FFmpeg comes in and actually does this weird trippy motion effect. So I'm going to go through the first 3 steps in kind of an abbreviated fashion because they're not the most important. The most important is using FFmpeg. But I will show you some things to help you prepare. So step 1 is preparing our corner logo. Now, I know most people do like a little animation when they introduce the logo. It's not just a still picture. So what I've done here is I have prepared a sample of my Able logo in the corner. It fades in over a period of 2 seconds, and then there's 1 frame at the very end. It's hard to see. But essentially what you want to do is you want to prepare a video which just has your logo where you want it. No input video whatsoever, not even a black background. You want to get whatever animation you want to introduce your logo, and then you want 1 still frame. So this is the still frame at the end. Essentially, after you introduce the logo, you are going to have some static representation of it for the rest of your video. You're going to want to have that static representation of it for at least a single frame. So in this silly example, I have the Able logo fade in. I have 2 tracks on top of each other. One of them is blurry and inverted to prevent the logo from blending into the video. So it's going to be like a blur around it. That's going to fade in over a period of 2 seconds. And then I have 1 frame at the end where my video has already faded in and it looks like what it will look like for the rest of the video. I won't bother rendering this because I already have. I'll show you what it looks like real quick. Yeah, it's just my logo fading in. Nothing special, but I do want to specify something important. When you render this video, you want to render it in any format that's under video with alpha, because we're going to be superimposing this onto the actual video that we want to edit. And in order to do this, it needs to be transparent, or else it's going to cover the entire logo with probably solid black or solid white. So I rendered this using under video with alpha mauve. I did this because this is, to the best of my understanding, a lossless compression format. I usually prefer to keep things as lossless or high quality as possible until I get to the final video. You don't need to do that. You can render it in a different format if you want to keep the size of your video smaller. It's just you may have to get a slight drop in quality in your logo when you do. So I recommend rendering this little animation in alpha mauve. We're going to close out of that because I already rendered it. The second step is we are going to prepare our video for the resolution that we want. So the test case I'm using today is the Warner Home Video logo. And what I've done is I have just applied transform. I've stretched it out to fill a widescreen. And I think it looked something more like, no, not like that, wrong way. Maybe 768. It looked something like this initially when I just stretched it out to fill a widescreen. And then I just manually adjusted these parameters a little bit so that it was, it looked a little bit better. It's not an exact science. There's no one right way to do this. Really, the point I'm trying to get is take your input video and prepare it to look best in the aspect ratio that you're going to be working with. Now, notice I said aspect ratio. You don't, at this point, want to render the video at the full resolution that you want. You do want to render it at the appropriate aspect ratio, which for most of you is 16:9 or a widescreen aspect ratio, because that's what most modern videos are rendered in. But the size of the video, I think a reasonable number is anywhere between 640 by 360 resolution and 1280 by 720 resolution. I chose to use 1280 by 720 because the original video I was working with was in a fairly high resolution. It was 960 by 720. Don't worry at this point about pixelation or distortion or anything like that. Just stretch your video to fill the proper widescreen format, or full screen if you wanted to full screen. That's going to be accomplished probably using transform. Now, the special part is that we're going to be lowering the frame rate. So I'm going to change my project settings. Currently, I have it at 59.94 FPS. This was just the original frame rate of my input video. So I'm going to go to my project settings. Now you'll see some presets under HD 720, or maybe you are not working at this resolution and you're under custom. The point is we need to make a new preset. So what I'm going to do is I'm going to go to my Manage Project Profiles. And I'm going to add a new profile, which I'm going to say is at 2 frames per second. I'll keep the size the same, but I'll set the frame rate to 2000 over 1000. I'm going to save this, close it, and then I'm going to set this to be my project frame rate. So this is going to be very hard to play. Kdenlive does not like working with frames this large or frame rates this small. So I'm not going to play in Kdenlive, But what you're going to do is you're going to render this after you change it. You don't need to render this in alpha. You can render this at any quality you prefer. I rendered this using lossless H.264. Reasonably fast to render, and no degradation in the video quality. If you're working at really high resolutions and you're worried about the size of your video being big, it's fine to use something like ultra high definition or even generic. It's really going to depend on your input video. And I'm not going to render that here because I already did, but I will show you what the output looks like. Isn't it beautiful? Now, there is one thing I forgot to mention. This isn't super important, but it's going to make your life a lot easier, so you don't have to worry about potential conflicts when you run FFmpeg. When you render it, you will want to turn off audio. You're only going to want the video because we're going to be getting the audio from a different source anyway, so we don't need it to come from this video in particular. You'll notice when I played it, it was totally mute. Now, Audacity. Something a little bit weird about my screen recorder program is once I start Audacity, it takes over my sound devices, and I can actually no longer use them to screen record. I've had this problem on multiple Linux distributions, and I don't know why that's the case. So I'm going to essentially splice in a separate recording around this point for how to use Audacity to get the desired audio effect where we use pulse stretch. But right now, I will play for you what the result should look like. So that is the result of abusing pulse stretch. And now we actually have everything we need. We've prepared our corner logo with the little animation intro and at least one frame where it is still. We have prepared the input audio and we've prepared our input video at the really bad frame rate. So now, finally, we get to the meat. We get to the good stuff, and this is where we use FFmpeg. So, I'm going to be detailing the command that I use for this and the anatomy of it. I will let you know when you have to adapt it to certain file names, but I do think that it'll be fairly straightforward once I break it down for you. So we're just going to make sure we've got everything we need in the folder. We have three things. Warner Choppy is the video that I have created with the Warner Home Video logo and the really bad frame rate to fill a widescreen. I have Dreamy is the weird audio that I made in Audacity. And I have cornerlogo.mov, which is my corner logo. So, what I'm going to do is FFmpeg -I, and none of these have spaces, so I don't need quotes. Warner Choppy -I corner logo .mov, and then -I dreamy.flac. Okay, that is not gonna fly what just happened here. You can't see the command if I type it that way. Let's change things up a bit. Will you be multi-line now? Yes, that's what we need. Okay, let's try this again. FFmpeg -I Warner Choppy -I corner logo -I Dreamy. So here I'm just specifying the input files that I'm using. The order is important because we're going to be referring to these files by their index. So the first file will follow this -I, and it's going to be whatever you called the video that you prepared your logo to have a bad frame rate in a widescreen format. It doesn't have to be exactly 2 frames per second, but I do think that that is probably the best frames per second to get the weird effect while still having some motion of the original video. You can try lower frame rates if you want a result that is a little bit less trippy. You can try higher numbers if you want something that's a little bit more trippy. Feel free to experiment with that number, but I digress. The second input is going to be whatever video contains your corner logo, and the third input is going to be whatever contains your weird audio. I'm going to specify some things that I think will help Windows users. Preset medium, size 1920 by 1080, R60, aspect 16 by 9. So everything I typed here is just specifying the format of the output video. The V codec is essentially the video container that we're going to be using, or the video format that we're going to be using. And I think HEVC is pretty good, pretty quick to render, and pretty good quality. With the medium preset means that it's going to render at a good balance between fast and high quality. I am upscaling this to full HD. That is just my choice. You can upscale this to whatever resolution you want. Usually I do this at 7680 by 4320, but that would take forever, so I'm not doing that in this tutorial. The rate, you can also set this to whatever you want. I usually do 120. I'm doing 60 for this tutorial for the sake of efficiency, and you set the aspect ratio to whatever you want. As for the audio, I'm going to set this to AAC, and I'll set the encoder to 2 loop. And all I've done here is I've said that I want to use advanced audio codec audio format with this -A codec. The -AAC encoder 2 loop, not really super important. This is just a personal preference, honestly. You don't need this. And the audio rate, sample rate, we're going to set to 48,000 hertz. None of the things that I've done so far, besides the specification of the input files, are set in stone. You can set the video format, you can set the video size, the frame rate, the aspect ratio to whatever you want to render your video in. Just keep in mind that this is the final render you're going to do, so you're going to want to choose whatever resolution, whatever aspect ratio, etc. you want to upload to YouTube. Now we're going to get into the good stuff. We're going to add the argument filter complex. This means that we are going to be creating a video by operating with filters on multiple input formats, on multiple input videos, I should say. And here's the chain. We're going to be operating first on our weird low frame rate video. This is where we're going to up the frame rate. So 0 means the first input, which is Warner Choppy in this case. And I'm going to set Interpolate equals FPS equals whatever you want it to be in the final product. It should just be the same as whatever you specified here. So I'm doing 60 for this demonstration. MI mode sets the algorithm that's used to fill in the blanks between frames. And we're going to set this to MCI, which means motion compensated interpolation. This is where FFmpeg is going to use some math to sort of guesstimate what the differences between the frames is going to look like. We're going to accept defaults for most of the other options, and then we will finally say SCD equals none. What SCD does is it essentially says, well, if the difference between frames is really big, then what could be happening is that the scene is changing. And I don't want to try to interpret the motion between scenes changing. That would probably look really bad. So I'm going to just skip doing that for this region of the video. But we don't want it to skip anything. We want it to look really weird, and we want it to try its hardest to interpret everything that's going on. So this section here is what really matters. It's saying we are upping the frame rate back to whatever we want. We are using motion compensated interpolation, motion compensated serpents with no scene detection. Comma. Oh, sorry, I made a mistake. These should be colons, because the comma is used to move on to the next effect. This one, we are going to scale our input video to whatever resolution we want. So what I've done here is scale, just as I'm upping the resolution to 1920 by 1080. W is width equals 1920. H is height, that's 1080. And then force original aspect ratio equals disable just means that we are allowing FFmpeg to distort the proportions of the video to fit our new resolution. And then finally, we're going to use HQDN, so we're going to put a comma after this, and we're going to do HQDN 3D equals Luma spatial equals 15. This is a denoiser. This is something that I usually apply to offset the effects of pixelation from upscaling. I usually set this to 10 when I'm trying to do this for actual semi-professional upscaling. For this, I tend to increase it a little bit because the motion is already really weird and blurry, so I'm not worried about making it more blurry by denoising it too much. Feel free to experiment with this value. Have fun with it. We are going to move on now. We have a semicolon, and something special is going to happen here, although first I need to backpedal a little bit. The filter complex chain is essentially a more cool version of something like VF, video filter. What filter complex does is it manages the application of filters to individual inputs as well as to multiple inputs. And what it does is it sort of feeds these videos as streams and maps them to each other in these cool ways. And what I'm going to do here is I'm going to say that everything that I've done to 0, which is my original input video, I'm just going to give that a name M. So I have some stream 0, which is my original input video. That's my low frame rate. I'm going to do all this fancy stuff to it, and I'm going to name it M. Now, when I add the semicolon, this tells filter complex to move on from editing just this one input to editing multiple inputs. And now this step is where I'm going to add my corner logo. And to do that, I'm just going to do M1 overlay. Ideally, you should have rendered the corner logo at the final aspect ratio and resolution that you want to use in your YouTube upload. It may still work if you didn't do that. It would probably scale it accordingly. But I find it easier to render it in Kdenlive at the proper resolution. So this was in 1280 by 1020, or 1280 by 720. This was in 1920 by 1080. And what's happening here is that I'm taking the output of all this fancy stuff I did, and then I'm overlaying input 1, which is corner logo, on top. This is it for the video, but again I have to backpedal a bit because I want to give the output of this a name, and I'm going to call it V for video. Then I'm going to map V and map 2. What this means is I am taking the output of this whole fancy chain, which I named V, and that's going to be the video stream of my output media. I'm also going to map input 2, which was my input audio, which I already edited in Audacity, so I don't need to do anything to it here. I'm just taking it directly and mapping it to my output video, which I will save as output.mp4. And it didn't like one of my arguments. Maybe it was AAC coder. There we go. So it's doing its thing now. In short, FFmpeg is taking the choppy, low frame rate video. It is applying motion interpolation and scaling. It's taking the output of that and putting my corner logo on it. It's taking all of that and mapping it to some output video that I specified as output. It's taking the audio that I already edited in Audacity, and it's going to add it as the audio stream to my output video. While this is rendering, I don't need to do much. So I'll probably pause recording here and let it do its thing. Okay, so my lovely video is finally done rendering, so we're going to see what it looks like. And there it is. You can practically feel FFmpeg struggling to do something with the nasty input that I gave it. Just trying anything. And that's what makes this effect special, you know? So, that was honestly a pretty involved effect. But it's one benefit that I like about it is that because it uses FFmpeg, it's pretty automatable. Sometimes I actually do the cropping and preparation for widescreen in FFmpeg as well, instead of Kdenlive, which lets me do the whole thing on one command line. And you know, I just think it's a really cool, neat effect that shows the limits of what motion interpolation is, and hopefully illustrates to you the underpinnings of how it works when it's used for more practical purposes. I really appreciate your attention today, and I hope that this tutorial was informative to you. Feel free to ask any questions you have in the comments, and let me know your thoughts about this effect. Thank you for watching, and have a good day.